We're here today to talk about reliability a little bit, reliability in the context of production engineering. I'm going to start by asking you guys to introduce yourself. Like, we know each other, but the audience doesn't know that. So let's start with you, Pedro.
Okay. My name is Pedro Canahuati. I'm currently CTO at 1Password, a security company that builds password management and security tools for infrastructure. Prior to that, I spent about 12 years at Facebook in a variety of different roles, initially focused on reliability and production engineering, building that out over the first 6 to 8 years or so. About halfway through my tenure, I started supporting infrastructure security, and then a couple of years later started supporting compliance, security, corporate security, and privacy. And so for all intents and purposes, effectively became Chief Security Officer, although I did not take the title, and spent a couple of years in privacy trying to rebuild sort of our centralized privacy team, and then left in 2021. So, yeah.
Great. What about you, Peter?
Peter Hoose. I'm the VP of Production Engineering here at Meta. I've been here since about 2010. My overall career arc, I started as an IC as a network engineer. I did that for probably about half the time, about 10 or so years. Before joining here, also as an engineer, the whole time has really been spent on kind of the lowest parts of infrastructure for the last, 15 or so of the 25 years. And then kind of more recently began supporting our AI teams, eventually our core systems teams, and then all of the broader PE teams. So this kind of encompasses everything from the lowest level of the stack in the hardware and software and systems, all the way up to the products, WhatsApp and Facebook and the things that people are familiar with. So it's really kind of end-to-end picture of these things.
Great. So for myself, I'm Francois. I've been running the reliability at scale for a while. So in terms of events and stuff like this, but the real job is really to run reliability engineering and reliability infra at Meta. We're the team that runs through fire, or when we're not running through fire, we're creating the disaster ourselves. I've been involved in all sorts of things, from incident management to also involved in core systems like you in the bottom of the stack systems and so on. So if I was to ask you, Pedro, even before coming to Facebook and Meta, what's kind of your story arc around yourself and computers and...
Yeah, so I actually studied computer science as a discipline. And when I left college, I decided I didn't want to actually spend time programming 8 hours a day. It was fun. It just wasn't for me. And so I really got a lot more into sort of systems and operations. I learned a lot about network. I helped build out data centers at companies that I was at prior to Facebook, Meta. Still can't get used to that, by the way. So I just learned a lot of different disciplines over time. But the thing that was always carried through was applying software to operational problems, and sort of applying the software discipline and building tools and building software to solve operational problems. And so throughout my career in the different companies that I did, I would always come in and recognize that things weren't efficient from an operational perspective, and then build software tools to make them more efficient. It effectively got me here to Facebook or Meta, and started applying the same things here. The interesting thing, though, is I sort of, my formative years were on the East Coast in Washington, D.C., working a lot with government companies, working a lot with enterprises and sort of higher industry. And they had a very sort of siloed operational model. But I never actually recognized that was the case. I just always pushed through in every company that I was in. And then I came here and recognized that we effectively had the same thing. Even though I think at the time it was about 1,000 employees or so, yeah. We had if I remember correctly, about 65,000 servers that we were trying to manage at the time. We still had a very siloed operational team that was focused on systems administration more than they were focused on tooling and automation.
I had a not similar story, but I started also on the software side. I actually studied electrical engineering and did a specialization in software. Ended up working in speech recognition for a very long time. And I got a massive amount of frustration from being on the software side and having my stuff not deployed properly. Mm-hmm. So I started to get involved a lot. And blending the lines and blurring the lines and getting involved when things were not working and stuff like this. And then I will always remember, for me, we're deploying a system for Schwab back then. Mm-hmm. And that was to get your stock quote and over the phone and things like this. And the people at Schwab, we have very limited large scale production experience. And they were telling us that we just don't know like how to scale what we're doing, and we did not know how it was like to package and then to like, to make it production ready, and that did stick with me. Like it still hurt today. I still remember this guy like talking to me and like okay, I don't know what I'm doing.
There's like a visceral reaction you have, right?
Yeah. And then it kind of like it changed me over time about like, okay, I really need to learn how to do this properly, and it influenced some career choice.
Yep.
All right, Peter, what about you?
I mean, I think there's a lot of overlap and dovetails. And actually, Pedro and I had this conversation many years ago, actually, because the very first day I started here, actually, Pedro was the very first person who came up and introduced himself to me. But I also grew up on the East Coast. Originally, my dad was actually a software engineer when I was born, which was extremely rare, in the late 70s, early 80s. But because of this, I was just born with a computer, which like nobody else really was. But I had a strange passion for fixing things and kind of breaking away from like the status quo, where you kind of get this mindset in your mind. And, to rewind back into history of this, I can remember some of my earliest classwork even in elementary school and high school, and just kind of getting really frustrated with how slow things were going and the progress that things are getting done and the way it was just supposed to be. And instead writing like software tools to make this problem go away. You fast forward to, the later stages. I actually didn't go to university. I dropped out of school at about 18, went straight to a startup, and got obsessed with just trying to make things faster and more efficient and more reliable. And I can still remember the very first project I worked on, which I was working at a hosting company, and they were building servers, and they could deploy one server at a time. And I was like, well, why?
A hosting company.
Oddly enough, Pedro and I both worked at that same company around the same time, which was Vario. And they were building these servers, and it was right behind my desk. I'm like, why can you only build one at a time? And they're like, oh, that's just how the system works. And I'm like, yeah, but why does the system work that way? And they're like, well, I don't know. I haven't looked at it. So I stayed late one night, and it turns out it was a really simple problem. It was a boot floppy disk that had a static IP on it. Switch it to DHCP, and suddenly you can deploy like hundreds or thousands of servers at once. And that insight, it just like understanding how people work and understanding how these things get in your way, has really just kind of flowed through my career. Like towards later in that point there, we started hosting Twitter. They came in with 10 or 20 physical servers. They grew to like 10,000 in the course of a year and a half. And every tool and every system broke in exactly the same way, where, this was the way it worked. But if you just looked a little bit broader, you could change that sort of status quo and move these things forward. So a lot of overlap.
It's actually really funny that you say that. When I was working at the computer lab at University of Maryland, where I was doing computer science, I also dropped out very close to graduating. So we ran the computer labs, and we loved to do sort of network LAN games at the end of the night. And each lab was like probably 30, 40 computers, right? And the problem was that if we wanted to get 6 or 10 people on it, we had to like basically re-image all the machines, do all the networking and all the LAN gaming stuff, and then re-image them the next day for the lab to
for the lab to be ready.
Yeah, exactly. But it would take a long time to like build all those computers. So a colleague of mine and I, he was also studying computer science, we just chose to solve that problem so that we could effectively re-image all the machines within an hour or two once we were done, and walk away, and then by the next morning the lab was fine. So again, it was sort of like that focus of, I don't like the way this works, I just want to fix it.
Yeah.
So do you remember the years? Like, I think it was the discovery of PXE boot.
Yeah, I mean, this was actually like in many ways like much later than you would expect, but also earlier. It's like 1999.
That's not late.
So, it's kind of a long time ago. But the interesting part was just going back to your part about like automation and software, which I think is a lot of like the real evolution and sort of revolution of production engineering and SRE and these things, is that at the time that was just like a foreign concept for a lot of system administration things. And meanwhile, when you looked at it, it's like, why would I do this, manually? Why would I put a floppy disk in here? Why would I type on this thing when I can just, write some scripts to make this happen? So.
Well, you guys were early. I think I discovered PXE boot. It was around 2005. You guys were early.
Maybe we're dating ourselves a little bit. So.
All right. You got to a point, you were at Meta, and then there was a point where the creation of the discipline or the function production engineering. There's a famous talk from SREcons, from Usenix that we can see, but tell us a little bit more about what was happening at that time. What were the conditions? Why? What happened?
So when I joined, we had a team named SRE, and they were built under the guise of what Google had built at SRE. And it was interesting. They were very disciplined. They were very mature in their way of thinking of the problem. They had these like 10 or 11 different signals that they used to recognize whether a team could be an SRE team and if they were performing sort of well in the discipline. And I remember looking at that list, and I think I crossed out every one but one of the lines on that list. And so I quickly recognized, one, we're not doing the SRE discipline that Google had built. And generally also the other thing was Google had sort of the thought process behind SRE was they were going to sort of hold the keys to production. And so software engineering was going to build a bunch of things and then eventually get to a maturity level where SRE could actually manage their systems and run them at scale. But you had to go through sort of like that maturity curve to get there. And we were not even embedded in software engineering at the time. The SRE team was effectively doing all the firefighting. They were moving actually network load balancers to slosh traffic back and forth between two different locations. They were rebooting servers. We had a process at night. So it was a shifted group, and we had a process at night where one person, before they left their shift, their job was to run a sweep across all the web servers to find out which ones were down and try to reboot them. And it was a manually run script that they did every night as part of their shift end. So that was kind of where we were, right? Like there was just no real, we weren't embedded with the software teams. There was no real sort of conversation happening at the time. We were on the receiving end of everything that software and infrastructure decided to do, and we're never involved anywhere upstream on that, right? And so, fast forward over the first couple of months that I was here, maybe even to a year, and I just recognized that that was not going to scale. It was not a fun job. It was not a place that anybody really sort of wanted to join. And when they did, they burned out really quickly because they were just doing anything and everything to keep the site up and running. And so a small team of a group called AppOps, Application Operations. And they were sort of embedded in the software teams. But sometimes it was one AppOps to like 10 software engineers, even 1 to 40. And there was a lot. And sometimes we even had one person with multiple services that they were trying to run in production. And that wasn't scaling either. And so over the years, we really focused on, well, we need to get out of the mode of being the people who run operations. We need to be out of the mode of being on the receiving end of every decision that people are making. And we need to work our way through to be much more equivalent to software engineers, to be able to actually gain the clout, to be able to solve the problems, to be able to have the influence that we needed. And then I'd say probably 3 years into my career here, that's when we decided to effectively rename AppOps and SRE into two teams, SRO, Site Reliability Operations, the team that had to do these sort of like the valuable work that was needed to keep the site up and running, and over time automate a bunch of our problems that we were having, and then take the AppOps team and expand that to production engineering and really sort of focus a lot more on how to get software engineers to maintain their services at scale. Right?
And if I was to contrast this, Peter, with today, like the world has evolved a lot. Like, there was this condition where production engineering was created, but now we're talking about like, the massive deployment, like we are not 10x, but maybe 100x bigger. The complexity is there all over the map. Like, we used to, probably back then, there was people racking and stacking servers and stuff like this. Today, we're at the point where, it's so complicated. There's so much logic in service placement that you need PhD to write solvers. So how do we contrast that creation versus
I mean,
now?
I think the fundamental problems we're trying to solve is still the same thing, right? Like ultimately at the end of the day, you're trying to reduce the amount of human time necessary to build and scale this thing. You're trying to, keep it reliable, keep it stable, make sure it scales to whatever that next inflection point is, and meet the needs of the business. I think what's really changed is you have a lot more capabilities and you have a lot more innovation. And what I mean by that is not that we're suddenly innovating more. That I look at innovation as an iterative thing. We've just got 10 years of history that we've built on since then, and you have a lot of tools and a lot of mental models that have evolved and allowed us to do this in different ways and not make the same mistakes over and over. Instead, we can apply something that we learned 2 to 3 years ago, now to 10 or 12 or 15 use cases to make it easier and easier. And that's become especially important because, I think one of the things that probably Pedro especially kicked this off was to try to move towards a much more like homogeneous environment where everything looks the same and we can control them the same way, and a limited amount of servers and footprint because this is the best way to automate it. But the world of today is really driving us in exactly the opposite direction. We have many different CPU types. You have small servers, you have large servers, you have storage systems, and so on. On the AI side, you went from really kind of non-existent to an explosion of many different vendors of different generations of them, all kind of operating the same time in the same fleet with the same amount of people. So the complexity is growing much faster than our people or systems are, and I think that's probably the kind of biggest change of all is we moved from a place where we intentionally tried to make things consistent, tried to make common tooling and things across the board, to a place where the business, the environment, and the industry has really forced us to try to figure out how to keep scaling and keep implementing these things while the world around us has gotten much crazier, much more complex. And I think the other part of that is that, I think early on we had, these great concepts around we work on reliability and efficiency and scalability. And I think that's actually absolutely still true today. It's just that there's so many more layers of this, and all of these things are P0s everywhere at every time, all along the way. And there's some things, like our job was always to keep the site up and running, and we did this really well. And I think that's still kind of the main, most important job today, but it's almost like a foregone conclusion. Like you can't not do that now. Now it's what do you do on top of that? Like that's the thing that must be true. Everything else is the thing that we're actually kind of doing is the day job. Whereas before it was like, that was the main job. Everything else was like icing on the cake, right?
There was a SEV, I can't remember what year it was at this point, but we had built so much automation to deal with the complexity, to deal with the failures, that things were resilient. They were really resilient, to the point where they were so resilient that if we wanted to turn things off, automation would fight against us to turn things off.
A few times.
And so the first time we tried to turn off the site, we didn't know how.
I think I remember that day.
It happened multiple times.
I'm sure it has.
Yeah. Like, it's multiple variations.
I remember that days.
Automation overriding what you're trying to do.
Exactly.
It happens all the time.
Yeah.
Back then, you probably faced that problem about how do I balance the growth of the infrastructure, like the product is growing and everything like that, with keeping it stable. So what was the biggest challenge in the early days in this area?
So when you have a set of people who are really operationally minded, and you have a people who are software minded, who don't necessarily see each other in the same way, you have two different push-pull mechanisms. The operational team is trying to slow things down because they want to wrap their head around the complexity. They want to wrap their head around the changes. They want to be able to maintain stability because most of the time, other than hardware failures that happen at scale for most companies like Meta, but not for most companies in general. Yeah. When something bad happens, it's because a human introduced change. Yes. And so from an operational perspective, people are really trying to prevent change from happening. Then you've got the software teams that are effectively incentivized and motivated to introduce change. They want to build new things. They want to build fast, fun stuff, right? Like we want to solve problems at that scale. And so they're going to introduce change. And so oddly enough, one of the cultural challenges that we had to do was get the operational team to recognize that change is a constant and we have to adapt to it and we have to become resilient to it. And then what we have to do is make sure that on the software side, we built enough sort of scaffolding to prevent some of these changes from going out too quickly. And one of Facebook or Meta's values at the time was move fast and break things, right? Like that's the thing that we knew, and we evolved it to move fast and with stable infrastructure, which was a good change for us that we had to make. But we had to apply that a lot more to the operational side. And in order to do that, the thing that we always relied on was if we can push a change that would cause a problem quickly, we should be able to push a change that fixes it as quickly or more quickly. And so that was a huge focus area of ours, which is if there's a problem, let's try to limit the blast radius. But if the blast radius was incredibly large, how do we recover quickly? And so that allowed us to move fast. And once we worked with some of the software and infrastructure teams to build a lot of those tools, some of the tools were built by production engineering, we actually were then able to give everybody the freedom and the ability and capabilities that they needed to be able to move fast. And yet we could recover quickly, which gave us, time to breathe, time to sleep, right? Those kinds of
Yeah.
things. So
And Peter, do you feel we can recover quickly enough today?
I don't think you can ever recover too quickly. I mean, step one is like, it would be ideal to never fail in the first place. The second step is to detect it instantaneously. The third step is to recover instantaneously. And like, I don't know, one of the best parts about this job is I don't think we're ever going to be done with that, right? We'll never truly, at least probably in my lifetime, be able to detect things instantaneously and recover, instantaneously. So no, we can't recover fast enough yet. I think we do pretty good, to be quite fair. Like, I mean, there's many, many, many small outages today that probably would have been fairly catastrophic, 4 or 5 years ago to the business that, just aren't noticed. And I think you hit this really well, is that it's by building a system that's resilient to the change. Like, that's going to happen. Outages are going to happen. Change is going to happen. You need to build and design your system to handle that. And if you do that, you can constantly move forward and constantly deal with a lot more of these outages and change without the same impact that you had before. So, like, at a big level, no, because you're never done.
Yeah.
At a small level, I actually think we do this pretty well, considering the amount of events and amount of change that occurs on any given day.
it is from the outside, now being on the outside, the perception is that when everybody sees an outage is that people don't know what they're doing, and it's not true, because there are so many things that happen on a day-to-day basis that are prevented, or outages that are mitigated, or things that are brownouts instead of full outages. And the public only sees the big things, right?
Yeah.
And they make their judgment based on that. And it's just far from reality. But you brought up an interesting point there, Peter. So, you'll never have instantaneous recovery. You'll never have instantaneous recognition of an outage. But that was one of our biggest problems at the time. We had a system that flushed its buffers from a metrics perspective every 5 minutes. And so, when something happens one time, you're not sure if it's a mistake or not. When it happens a second time, it could be a trend or it could be a fluke. By the third time, it's a trend, right?
Yeah.
It's either going up or down. And our systems took 15 minutes to flush to do that, right?
Yes.
And so I remember a really concerted effort from our monitoring teams to really bring that down from 5 minutes to 1 minute. I don't know if you guys have gotten it any further than that, but
We're going to the next phase.
excellent. That's wonderful.
Yes.
But 1 minute, changed our reaction time from 15 minutes to 3. And that was a huge change for us to be able to actually recognize, A, is the problem actually happening in multiple places? B, when we put a recovery in place or mitigation in place, is it recovering quickly? And that made a huge difference for us. And something that, honestly, like even now, being outside of Meta, is very odd. Most companies don't have that level of sophistication or that capability to be able to do that. And so oftentimes in outages, people are just waiting. They're waiting for something to tell them if it's working or not. It's not a great place to be.
So you talk about from the outside, the perception is slightly different. So you had the opportunity of being the CTO of 1Password, and you're still there. What's the big thing that you learn, being outside of Meta and Facebook? What's the big hurdle that you had at the beginning into understanding their culture and understanding what you could transition with them and so on, what you could adapt?
That's a lot. But let's see. A couple of things that I've learned over the years. One is the cultural values are generally, they're sort of transferable to a point. You have to recognize the company that you're in, and you have to recognize what you can and can't make a change on. Facebook Meta had a very interesting engineering culture. It had one that was very focused on moving fast and sort of getting things done quickly. And you measured your impact based on whether or not it got done or not. Data won arguments, those kinds of things. When you go outside, if you haven't built up an engineering culture in the same way, a lot of those concepts are very foreign to people. Like when you start talking about some of them, they kind of look at you sideways like you have 3 heads. And so you have to spend a lot of time explaining a lot of those things, explaining the concepts of those. If you have an engineering team or an operational team that hasn't grown up in the same way, they don't make the same connections. And so we had to build really sort of a cultural norm of learning through experimentation, learning through failures. We didn't have feature flags, for example. We didn't actually have product analytics because from a privacy perspective, it was sort of taboo to do that. And so we had to find a privacy-preserving way of doing that. And all those concepts are just foreign, and they were foreign to 1Password. They're actually pretty foreign to a lot of companies, particularly a lot of companies that have started in the last 5 or 10 years or so. And so I had to spend a ton of time doing education, I had to understand sort of like the culture that I could adapt to and take some of the learnings that I had and some of the values that I had, but then adapting them to the company to make sure that they actually worked. Being the CTO, I'm not just focused on reliability. I'm focused on the engineering side of the house too, and pushing out changes quickly and making sure that we can get the software into our customers' hands as quickly as possible. I have to focus on data and IT and security and privacy and all those different functions, including the infrastructure and operations side of the house. And so it requires an interesting mental shift where you have to figure out that there's always going to be a certain set of motivations for certain different teams, and you have to find the balance between all of them. That was not necessarily something that I really understood here, because I could see it from afar. The software teams pushing against operations, that's fine. We solved that problem, right? The advertising teams pushing against other teams to get things done faster, et cetera, et cetera. But it's not the same. You're limited in your scope, you're limited in your view. And as a CTO, you have to try to make everybody happy at the same time. That's a very different environment, right?
And Peter, on your side, looking at production engineering for the future, about what we need to do. And I think the last 2 years were a good example about it's not just, sure, there's the reliability of the site, but we also have to make big changes. We have to move mountains, literally data centers for making space for AI. We have to react quickly to product changes. We have Gen AI is uptaking, and then we have to react super quickly, and then our skills are changing. It's not just our ability to debug or to remediate to stuff. We need to be able to plan also. So what do you see in terms of future for the discipline?
That's a great question. I mean, I think there's the things you hit on there of just skills. A production engineering role is always kind of evolving with the technology, the new hardware that you need to operate on, the new operating systems, the new paradigms, and so on. But I think the higher level part that's really interesting to me is one of the values I think that we provide better than anything else is just trying to get that balance between things, right? And historically, because reliability was really just rough in the kind of early days of the internet, and systems weren't really designed to be scalable and sustainable, and we had to sort of make that happen. Now that's in a pretty good shape. You can spend time chasing the next, third or fourth or fifth nine of uptime, or you can take advantage of that a little bit and figure out, how you can move a little bit faster, how you can take a bit more risk while achieving the things that you need to get done. So I think, some of that evolution is exactly that. It's trying to figure out where we can take a bit more risk and move a bit more faster without compromising the site and the products while enabling this, crazy change that we're seeing. And you will see that time and time again, it's the PEs that are the ones who are called upon to try to help the business figure out where they want to go on this. So do we want to change out this region, this region's hardware mix to, meet the needs of the business in terms of getting more AI hardware in there? Do we want to, downsize this region? Do we want to, roll out these changes into the products, faster than we have in the past? All of this stuff comes down to getting that thing right, that I think ultimately this role is the one that figures this out, right? So you go back and say, okay, hey, the site is running at 5 nines. We can push it a little bit faster. We can run it at 4 nines. And this is very counterintuitive to all of us, because I think all of us are still striving to get to that 100% uptime, magical theoretical metric. And instead we have to figure out what is good enough that allows us to keep going faster. And I think this is really great in the best analogy for this is like a Formula 1 race car. If you want to go as fast as possible, it's not just pure acceleration and turning, right? You got to get the balance of acceleration and deceleration and turning and weight and all of these things together to make this go fast. And I think that's ultimately where we're pivoting to now.
And that's an interesting point, because I think, if you use the analogy of the Formula 1, there's a lot of math involved, right? There's a lot of physics, there's a lot of physics, a lot of math involved. And that was something that I don't think we actually really recognized early on, that there were going to be some levels of complexity that we needed to bring experts that maybe we didn't have on the team, and or teach some of the folks to be able to actually do those kinds of things. And over time, you found this sort of emergent behavior on the teams, both on the software and operation side, where people were looking at it more as a sort of a computer science problem, right?
Yep.
Or a mathematical problem.
Yep.
And that became so much more interesting than just purely software, hardware, operations, right? Now starting to look at things to figure out what the future could look like and calculate that out, and then do all the mathematical equations that we needed to be able to actually understand what things were going. That changed the discipline over the years. I think it changed the discipline of infrastructure and production engineering. But honestly, it was, to your point, I think it was production engineers who were really the ones pushing on that and saying, no, even the way we think about this problem now is not going to get us to 3 months, 6 months from now.
I think that's a great example too, just because, to build on that a little bit further in math is, historically you would provision servers and it would work and it would be good. And, you fast forward 4 or 5 or 6 years and you're provisioning 1,000 servers a month to suddenly you're provisioning tens of thousands or millions. And you forget to look at these things and you go back to it and you get really stuck in this matter of like, oh, this is good enough. This is the way it works, until you start doing the math, until you start looking at this and going, wait a minute, like the laws of physics say we can do X, and currently we are doing X times 10, way slower than we should. We really need to kind of bring this back and, see how fast we can go and see where we can, increase the velocity of these things and only bound ourselves in things that are actual hard limits versus just the, that kind of things in your mind, because it all becomes, the way you've built it, the way it's always worked, and you forget that, the only real constraint is the laws of physics.
And actually building a little bit more on what we were just saying there, one of the things that I love about the discipline that I think a good production engineer really sort of showcases is that tenacity to never give up.
Yep.
You see an anomaly, you see a problem, you see a blip, and then you see it again. And then you see it again a couple of days later, and you start thinking, why is that happening? Yeah. And then you start digging, and you start looking into it, and you get to levels of depth of hardware and software that like I never considered I'd ever do, even as a software engineer. And you find some amazing, interesting things. At scale, you will find way more interesting things than you will in smaller environments, for sure. But that tenacity is sustainable, right? Like you need a set of people who are going to do that, because to the same point on scalability and future, they're going to look at that problem and they're not going to let it go. They're going to try to solve that problem over time, right?
How do you find people that have that tenacity? This is something that, I know exactly what you mean. Like, for myself, I even it's something that my wife will say I have it way too much in my life.
my wife will say the same thing.
I will latch it to something and really go after it, and it will not get out of my head. But it's kind of like easy once you work with someone to identify that. But how do you figure this out from an interview point of view?
I mean, so yes, it comes from an interview point of view, right? Like you start to learn a little bit about that. I think the best ways that we found it were, so we sort of evolved over time what our interview process was. One is we stopped asking puzzle questions. We stopped asking trivia questions. We stopped asking, honestly, like even, what command line would you run to do this thing? That wasn't actually useful. We started asking complexity questions around, I'll give you a problem. How would you go off and solve it? Just tell me a story. Tell me what you would do. We would ask the questions around being involved in an incident. And we would leave it pretty open-ended. My question would be, what's the latest incident that you were involved in? What was your role? What did you do? And then they'd tell me the story. And then I'd ask the question follow-up, which is like, okay, what would you do differently? And there's a huge signal in that, because if you're somebody who learns through failure, if you're somebody who has that tenacity to never give up, they'll tell you a story about all the things they learned along the way. They'll tell you a story around how they found a different environment, or they went and grabbed a couple of people that had knowledge that they didn't have that they wanted to learn from, and then incorporate that into their solution. And so that's the learning aspect of it is really the thing that made us successful, because we would just never stop learning. And whether that comes from sort of leadership or not is a question that we can all ponder forever. But I'm that way. I can't, like, once I start learning about something, I really want to spend a lot of time on it and trying to learn as much as I can in the moment, right? Like my wife, she's like, you got to give up sometimes.
Yeah, you got to give up.
I think, a trait in there that you're kind of highlighting this, it's like curiosity. You ask somebody how something works and, you explain it to them or they explain it to you, and they can keep going further and further and further, right? And they can go beyond like what they should know. And I still distinctly remember probably one of my favorite interviews ever, like to get a little bit specific. And I was just asking somebody like, hey, how would you detect if, somebody had started listening into your lines on a network infrastructure, right? And we went through all like the well-known, standard versions at the time. You could tap the lines, you could, put a splicer in there or something like this and listen in. But we went further and further, like way off into obscure lines of like, well, would it be possible to do this without somebody detecting it? Would it be possible to, listen in onto fiber in some way? Could you cut the sheathing off and find packets that are, kind of bouncing out of there? And how do you like both figure out ways to do that, but also find ways to detect it? And I think in every time I've gone through and interviewed somebody, even if I don't know what their skills are, if you can find that thing that they're curious beyond what their job that they're currently required, I think you'll find that they can be successful just about anywhere, right? So if they keep poking and keep building and keep iterating, they can go further. I think that Other great example of that, like one challenge we had somewhere around 2012, 2013, is you start to look for people who've done this before, which at a certain size, you're not going to find them anymore. So instead you have to go back and say, all right, like, do they have a rack of servers in their house? Have they built an LLM for fun? Have they trained different models? Have they tried these things that you wouldn't expect them to do at the scale that they're in? And that's probably somebody who's going to be great. So you're not always going to find the person that has the skills you need, but you can find somebody who can adapt and grow just by looking for these things.
And actually, I've always thought that, in essence, tech is easy when you have the right people, but people are hard. And you have to find the right people to make the tech easy. Right. And so that's also the thing that we actually did a lot, that we did really well, is we focused on the human. We focused on the individual and knowing who they are, what motivates them, why they're motivated by that. And then it helped us actually really sort of put them in a place where they could shine and their strengths could come out and they could learn more, as opposed to oftentimes where you're trying to do is trying to mitigate a weakness and make sure that they're not put in a place where their weaknesses shine. Right. And so that actually helped us a lot, because in production engineering, it's not something you were taught in college, right? Like you have to learn on the job. And everybody that came into the team, either they were a software engineer that became sort of operationally minded, like you were talking about, or somebody with a very different background that then either adopted operations or software engineering as a discipline. But honestly, that they came through various different mechanisms. And so really what you had to do is focus on them, and then that allowed you to sort of deploy them wherever they could and wherever they could have sort of that impact, which made it really great for the discipline. It allows us to really sort of grow in a variety of different ways.
So Peter, I see you do have the tenacity, but I also see that
Thank you.
you're able, but you are able to bring a group with you.
Yeah.
And that's a second skill that I believe is important, because like, okay, I can be tenacious by myself in my corner and be like grumpy about something, and I might solve 5% of the problem. But how do we find people that have like this mindset, but they can also carry a group with them?
I think that it's, for better or worse, it's being able to explain the problem in a way that other people care about. And everybody cares about different things. One of the challenges I often have is whatever your business is kind of focused on. Most businesses are focused on probably growing revenue or growing users or growing something. That might not be motivating to the engineers on your team. In fact, they might only care about reliability. They might only care about efficiency. They might only care about serving end users. And I think if you can break down what it is you're trying to do into a set of problems that are technically interesting, you'll motivate one set of people. And if then you can add in the part of this that's the value that they care about, I think you'll motivate the rest of the people. So you can say, all right, we need to go solve this problem because we need to, scale past this limit. That's like really technically interesting. There's a bunch of hard technical challenges we need to solve. That's going to get a whole class of people excited. The next part you're going to need to say is that, the business needs us to do this because it's going to drive up revenue or drive down costs or something like that. Now you get a whole bunch of people who are business minded, oriented towards it. And then the kind of third part of that is the, benefit to the users of the product. This is going to make this thing go faster. And I think most of these problems, like the only reason you care about them in the first place is that they solve one or all of these things. So if you can just help to figure out what that is, I think you can get a whole lot of people going along the long way with you. So I think if you can find someone who can take a complex challenge, break it down into problems, explain the different motivations, and explain why it matters to the business, get a lot of things done.
And actually, what you were just saying there is really important. Some people are going to be motivated by solving a problem that customers can see, right? Or the users can see at scale. Some people are going to be motivated by, can I get my friend who's sitting right next to me to be more efficient? And that's incredibly important. You have to find the types of people who need to do both and want to do both, but they're not the same people. They might have different skill sets, and you might have to actually ask them to do different things to be able to actually tap into that motivation and make them happy in that respect. This is a value that Peter and I have talked a lot about in the past, and I think we both share, and most of production engineering leadership has shared forever, I think.
Yeah.
It's the people, right?
You talked about a part there too that was a little bit before about like finding the strengths. I think that's the other key part is, if you ask somebody who really likes to build big new things to go fix, today's fire, they're not really going to be motivated or excited. And the inverse is also true. You can find people who really just like to fix things, and if you ask them to go build a new bridge, they're going to be really bored. So what you're trying to ultimately do is understand all these different motivators and understand the different strengths of the people, and build the intersection between these things. So align that strength to the problem, to the business.
Great. I'll move us to very fast question.
Okay, sure.
Lightning round.
The terms The term SEV is well known in the industry. It's site event or, it's production incident. What's your favorite one?
I do think the favorite one was the one I was just talking about, which is when we had to take the site down. So we had an engineer in an internal team that was doing some database maintenance, and they dropped a permissions table on Gatekeeper. And we opened up every feature to every user on the internet. The site went down. We didn't know why, but it went down, and then we recovered it, and we started bringing things back online slowly. And then we started getting these messages from friends who were saying like, hey, this new photos feature is so cool. And a couple of us were like, wait, we haven't released that. Like, what do we do here? And so immediately one of the engineers came back on RSE and told us what had happened. And I ran over to my boss, Jay, at the time. And I said, Jay, we have to take the site down. He's like, what do you mean? I said, well, we released every feature. We have not really privacy checked everything. We don't know what we've actually just released to everybody, and we can't recover it without doing that. And so he said, okay, get ready. And then he ran away. Well, it's like, what do I do? So I went back to my team and sort of went back to the desk and said, hey, we need to take the site down. And to the point that I was just describing earlier, we had built so much automation to be resilient to outages that we didn't actually know how to do it. And so in the moment, we sort of like brainstormed for about 3 or 4 minutes. And one of the engineers came up with the idea of basically bringing down our TTL on DNS, which was 30 seconds at the time, down to 5 seconds, and then black holing all DNS traffic. And so we said, okay, get ready for that. Waited for Jay to come back. And Jay said, okay, go for it. And I said, where did you go? He's like, oh, I talked to Mark and Trepp at the time to tell them we were going to take the site down. And I asked, what did they say? He's like, what do you mean? He's like, well, when you asked them if we could take the site down, he's like, I didn't ask them. I told them. You told me we needed to do this. And I said, okay. And so now here I am, go back to the desk and ask the engineer who was going to take it down. David was his name. And he was about to hit the enter button, and he was scared. He was like, I don't know what's going to happen here.
I don't know what's going to happen.
And so I sort of put my hands on his shoulders and I said, it's okay. Don't worry. You won't get fired. And he hit the button, brought everything down. We fixed it, brought it back up. But I learned a couple of things in the process there. One was when you're sort of like in charge of a real big incident, people are going to listen to you if you know what you're talking about, yes. Right? And they're going to sort of take it seriously. And so it's not about asking for permission. It's about understanding that in an incident, you're going to have to make some decisions that are going to be hard, and you're going to have to stand by them. And if you can stand by them, great. The second is there's still humans who are involved, and humans have emotions, they have fears, they have, all these things that you have to deal through, particularly during incidents where they're really hard, because everybody's stressed. And when everybody's stressed, all their inhibitions are sort of like, taken away, and they have a hard time making decisions, sort of communicating, all those kinds of things. And so we had to make it easy for us to be able to work through a lot of incidents from a human communication perspective. So we built a lot of processes after the time to sort of help people along in that. And so it's a fun one because I think the story is fun.
Yeah.
It's a fun one because, again, there's a lot of learning in that one small event, effectively. It was a big event for us, but it was a moment in time where we learned a ton by doing something in the moment.
Oh, this is an easy one. It's the SEV that never happened. The second best is the SEV that nobody noticed. But I think the third one, because it's really about, it's like what you learn from this and like the principles and things you take away. And I can still remember, when I worked here as an engineer, the first SEV I caused, and I caused a pretty big outage at the time, actually a very large outage at the time. And, I was feeling really bad. I was worried about I was going to be fired. I was pretty new on this job. I'd made the mistake. It was just purely a human error. And I remember going into incident review afterwards and telling the story of, hey, I made this change, but here's what I did to make that less likely in the future. I added some better monitoring, I added some tools and automation. So this is like much less likely to happen. At the same time, the actual change that I caused took about, maybe 5 minutes of interruption, but the site had like 30 minutes of impact. I remember, actually, it was Jay still at the time, and he was just like staring at me after I explained what happened. I was like, all right, this is, he's like, get out, right? Yeah, I'm like, all right, I did it. And he turns to me, he's like, all right, that seems reasonable. You detected this pretty quickly. You mitigated it pretty fast. You have a good story about how you'll do that better in the future. And he turns to another team and goes, the network was down for 5 minutes, but your service was down for 20 minutes. You need to build your service to be resilient to those kind of outages, because the racks are going to fail, the power is going to fail, the data center is going to fail, and so on and so forth. And I think that model and that principle of trying to build services that are resilient to that failure has really stuck with me. So like more than anything else, I think the SEV where you can build some new principle or reinforce a principle is always my favorite. after the one that doesn't happen.
Yes, after the one that doesn't happen. It is interesting the SEV that you mentioned, because I was involved in a similar thing
Oh, I'm sure.
with Instagram, where I was working with someone who actually tried to recover like a keeper database for Instagram, and then we forgot a control character. So we recovered the database because they had lost all the feature gating was lost suddenly. We recovered it, we forgot a control character, so when it started to read, everything went down. And I remember at that time, I also was the one who told the person to actually press the button, it's going to be fine. And then we're asking the Instagram people, hey, how's it going? And they said, we're down. And I'm like, what do you mean down? It's like just a little bit? No, completely down. So it's funny that it's like, that culture did stick. And the no blame is actually very important. It's part of how we handle incident. It's part of what gives people like the freedom to kind of like think under pressure and allows them to solve the problem.
And I think if you make it safe for people to take risk, if you make it psychologically safe for them to be able to admit that they made mistakes and not get fired in the process, and use it as a learning experience and sort of failing forward around those types of things, then people will come up with better ideas. Because you're not blocking them, you're actually unlocking them. And that was, again, sort of a cultural value that we had all along production engineering and Facebook Meta, and still, I think still to this day, it still stays, which is we need to figure out how to unlock people's abilities, not block them from doing other things.
I think that, part of your story there too is just what different people in the organization can do to help somebody in the incident. At the end of the day, at a psychological level, you go into like fight or flight response to this stuff. And I think most people's response is something that looks like freezing. They just sit there and they're like, I don't know what to do. And as soon as somebody can come in and just say, hey, it's okay, I'll help you out, go make this decision, I'll take the blame for this, or I'll take the accountability for it, you can suddenly unlock a whole lot of things really, really quickly. And I think anytime you get into incident reviews, it's a very common pattern that you're like, all right, this isn't moving very quickly, what's going on? And you can find out that it's just somebody stuck that's afraid to pull the trigger or afraid to press the button to, to make it. So just sort of freeing that up is a big deal.
All right, next fast question.
Okay.
Most impressive system that you've worked on, that you were like, oh my God, this is good. Like, this is something that I'm genuinely impressed.
Wow, that's going to date me. Early on, I don't know if you all do this anymore, but early on, we embedded memcache, what do you call it? Memory, no. God, now I'm blanking on the term. What is it? When you clear the entry in memory, what is it called? There's a name for that.
Like clearing the cache or?
Cache eviction?
Cache eviction, thank you. Okay. All right. So memcache. We used to embed memcache cache eviction into the MySQL binary replication flow. And we used to read it from that. And then we used to be able to sort of validate the cache at every cluster. And at one point or another, we were trying to figure out how to bring up new clusters, but they were cold. And when they were cold, it just took way too long and it hit the databases way too hard. And so we had to figure out a way to bring up a new cluster, but bring it up in a warm fashion. And so I started talking to the memcache engineers and the database engineers, and I said, wait, we embed this in the stream already to invalidate. Can we embed it to replicate it? Can we bring up cache in a way that when we're writing to one cluster, we also write it to another cluster? And that's the new one that's coming up that's now sort of cold, but now will become warm once we give traffic to it. They looked at me and they're like, yeah, I don't see why not. But nobody had ever thought about that, right? And it was just sort of a conversation about those types of things. And we built a system that was pretty sophisticated. I don't think memcache is used that much anymore at Meta. But it was just a pretty slick, simple solution to a very complex problem.
I'm going to blank on the actual external name for this, but our, container management system, what's the external name for this? Twine, I think. Yeah. It's less the system itself. And I think you'll find, at least in my case, I really like the things that have changed the way you think about something. And I think that really fundamentally changed how we thought about operating our fleet. Because prior to that, every team managed and built and maintained their servers. They deployed their operating systems, they deployed their patches and all these kind of things themselves, which seemed totally reasonable at the time. But you fast forward to today where, you had 500 people managing servers back then, to today it's like a team of 20, but the fleet's 10 times the size. Like, that fundamental shift and what that unlocked in people's day to day, and how we've managed a fleet, and the overall efficiency of the humans, the fleet, and everything in between, it's just like mind blowing. And I don't think, if I rewound 5 years ago, I would have really realized that until today. And you kind of look back in hindsight, like, I can't believe that the average team was probably spending 20% of their time just to maintain and manage their servers, whereas today it's just like a foregone conclusion. You don't do that, right?
We don't do that anymore.
Yeah, so just like really changed the game of how we did things, and probably got us from, it's hundreds of thousands of servers to millions of servers. Wouldn't have been possible without it.
Favorite system to use, though? ODS and Scuba. I'm not sure what they are. Yeah.
Scuba is amazing.
Amazing. Like, those systems that we built are just, the envy of the industry, and I wish I had them. So.
For reference, Scuba is...
There's an external version of it.
Yes, there's an external version, but it's like monitoring on steroids, where everything is in memory. You can slice and dice any way you
amazing.
want. Yeah. Like, for me, like my most impressive, it's not even a system, it's kind of the concept. Like, I came from Yahoo before, and where a lot of protocol between like systems were very different. Like, you can have native stuff, you can have MySQL protocol, you can have REST, you can have some custom HTTP. For me, what has been super impressive is Service Router and Thrift.
Yeah.
The fact that it's the communication channel that's the same everywhere, you can debug everything, that you can black hole the traffic anywhere in the network, has been like, an amazing discovery. Yeah.
It's crazy how much something can, how powerful that is, and how much we take that for granted. I think once you've had it and it's true of any company anywhere, like there's some unique thing that you have that is totally different than everyone else, and you kind of come back to a new company and they don't have it, or you go back to your old company, do you have it? Like, it's game changing. Yeah.
All right, I'm going to move to one last piece of advice from both of you. So if you had to implement the concept of production engineering at your next new startup or your next endeavor or something like that, what would be the best piece of advice you would have?
So I've actually had to do that. When I joined 1Password, I inherited a DevOps team, which was very operationally minded. Was very siloed from the software teams. In fact, it was an interesting shift from when I joined Facebook. Sort of software engineers didn't want to deal with production outages. At 1Password, they did. We just didn't give them the capabilities to do that. And so the way that I've sort of gone about it is effectively trying to figure out what fears everybody has around some of these changes, and then trying to address them as best possible. How do you build the sort of like the tools, the cultural norms that you need to change, the set of scaffolding that you have to build to make it easy for people to take risks and quickly to recover from those risks. Build out incident management is honestly like the top advice that I would say is build a blameless incident management process, where we still to this day start every incident review every week telling people why we do it, why it's safe to take risks, and how we actually deal with it, that they're not going to get fired, that we're here to understand and best sort of like mitigate it for the next time. And then the other thing that I would say is understand the sort of the values that the people have for why they're doing the work that they're doing. And because I do think that the values of a production engineer are very different than just a straight software engineer or a straight operationally minded sort of systems administrator. And so tap into those values, and that's what you can use to get there faster, and make sure that people come along for the ride. And sometimes they don't, sometimes they won't, and that's okay. We just try to work with them to bring them along. And if they don't, we've had a good sort of like working together, and now it's time to part ways. So, yep.
In a way, I sort of went through this experience, parallel to the evolution that Pedro explained on the services and systems side. We did this for networking, and networking in many ways was a lot further behind than the systems and services side. There wasn't really that much automation there, and we had to, bring people along. And I learned a lot from that, which is that if you can get back to what they care about and what they're interested in and what they're passionate about, I think a lot of these things are somewhat obvious after the fact, right? You're like, do you really want to get paged at 3 in
Yeah,
the morning
yeah,
to,
yeah.
reboot a server or to upgrade a router? And they're like, no. And we're like, okay, so like, let's get rid of that. Do you really enjoy manually, building configuration or, whatever these things are that you do by hand? They're like, no, not really, right? So it's like, once you can show them the value of these things, I think most people like slowly, iteratively kind of get there in their mind. The next part is actually just showing the result. So kind of to your point of what I would do first, I would explain that value proposition, and then I would find something that we can move the needle on very quickly. Maybe that's the amount of alerts that you have, or maybe that's just some manual operation that you do, or maybe it's rebooting the servers every night. And like, we're going to go solve that really quickly so that people believe it, they see it, and then they just want to compound on that interest forever.
Yeah, actually, it's a really good point, is measure the impact of the work that you do, because right in the beginning, it's pretty nebulous. But if you can point to something that has gotten faster or is done more often, then you'll see the impact of that. And at OnePassword, for example, one of the things that we did was we actually now have releases on a timely basis all the time. We release, on a schedule,
Yep.
And we do it consistently.
Yep.
And we're reducing that schedule every time we get there. And so reducing that schedule has been a huge boon for the company. And so that's one of the things that production engineering has sort of like unlocked, right? So. Yep.
It's amazing how powerful a graph that goes up and the right can be
Yes.
to anybody, right?
Down
So
or
like,
up. Yeah.
just like move that metric, and people are super excited.
All right. Well, thank you. Thank you for the conversation.
Thank you. That
Totally
was awesome.
appreciate it.
Yeah. Thanks for having me. That was fun. It's really good to see you, man.
Great.
Yeah.
All right.
That's it.